is going to be gaining a thorough understanding on process capability and process performance. Going with the normal English, the English meaning of capability and performance. I hope all of you will be able to differentiate easily, right? When to use the word capability and when to use the word performance.
Oh.
If you know when to use the word capability and when to use the word performance, you actually know when to use CP/CPK and when to use PP/PPK. CP/CPK represents the process capability indices. PP and PPK represents the process performance indices. Capability, the meaning is, what am I capable of? I may be capable of many things, but finally, what matters to you as a customer? My performance matter to you. So what customer will feel, the customer experience truly depends on the performance, not merely on your capability. I may be capable of, many things. I can talk about the Six Sigma tools and techniques. But what is that I am delivering right now? That is important to you. So there is no point of looking at CP/CPK and no feeling, satisfied with it. No. In real time, what is the experience your product, your service, your process will be giving to the customer? That matters. That is very, very important, for the success of the business, any business. So hereafter, I want each one of you here to look at PPPPK instead of CP/CPK. Earlier, we told you CPK is better than CP. Now I'm telling you PPK is better than CPK. Always, we should move towards the better one. Yes or no? As we mature and mature enough, as we become, more and more experienced, more and more matured, we move towards the best of everything. So PPPPK is absolutely, without any doubt, is a better metric of your process performance from the customer standpoint, from the long-term standpoint. If you want to see your process capable even in the long term, then you must rely on PPPPK, not just on CP/CPK. Right? So singing a song while taking bath will tell you how capable you are in terms of singing. But singing in front of an audience of 1,000 people will tell you how good you are in performing a show. Both are not same, isn't it? Singing in a bathroom is much easier. Everybody sings so nicely. But singing in front of a big audience is challenging even for a professional singer. Yes or no? You should be able to control your nerves and everything, manage, you should not be afraid of seeing the crowd, but still perform. That means in long term, the challenges will be much more than the challenges you have seen in the short term. Yes or no? The kind of challenges you will be facing in the long term will definitely be, much more bigger than the challenges you have noticed, you have controlled in the short term. So controlling a process in short term requires, monitoring few metrics. But controlling a process over a long term definitely requires monitoring the process, monitoring the process in a deeper manner. Your sampling frequency has to be strengthened. Your data collection period has to be strengthened. Even though I speak about data collection period, it is not always, the solution. The solution is not always collecting more sample. No. That is one of the solutions. If you really wanted to understand the long-term performance, yes, one way you can understand the long-term performance is stretch your data collection period. Instead of collecting data over a week, collect data over 2 weeks or collect data over 1 month. That is definitely a good idea. Another thing what you can do is you can increase the sampling frequency or data collection frequency. And finally, you can also increase the sample size. Even though you have all these possibilities, sometimes situation may not allow you to increase the data collection period. Agree, all of you? Within 1 week, you have to finish off everything. So you cannot say no to any given scenario. Whenever your boss asks you certain report, you must immediately prepare the report and submit. That is what is, expected from you. So even though there are ways to stretch your, data collection period and increase your sample collection frequency, increase your sample size, even if all of these things are not possible, still by carefully making use of the available data, you can still estimate the performance. That is the, hidden secret. Not many people, easily understand this. They completely confuse CP/CPK with PP/PPK and PP/PPK with CP/CPK. And, they mix up things, sampling plan, sampling frequency, sampling technique. No, this is an altogether a different subject. When it comes to sample size and samples and sampling technique, the more is better. But at times, you will be governed by the situation. Everything required within one day. You cannot say, sir, in one day we cannot calculate something. No, you cannot say. Whatever best can be done, you can do it. But what you need to know is, you should know how to use the data. You can use the data in a particular manner and calculate and understand the risk involved in the particular process from where data is collected. Whenever you want to understand the risk, what is exactly required to be understood is the uncertainty in the data. What is uncertainty in the data? The variation in the data. So what is variation in the data? The standard deviation in the data. If you calculate standard deviation in a particular manner, you will understand the short-term performance or the short-term capability. If you use the same data in a slightly different manner and calculate a new way of, and calculate the standard deviation using a new way, with the same data, you can calculate long-term performance also, right? So I will take you through my slides and now you will be able to understand the exact difference between process capability indices and process performance indices. So first, let me again take all of you through the what you call the capability in indices. Even though you have already understood it, I want you to master it with a little more clarity. Yeah, very good. I think this has got everything. I have shared all of these slides with all of you. Please go through all the slides I am sharing. And also I will recommend some good books for all of you. And maybe I'll share a couple of good books also. And you can read them, to gain a long-term understanding about all the tools and techniques. Okay, so process capability analysis. See here, I have written, you need to know your potential as well as you need to know your reality. Just by singing so nicely the song, you should not think that you become a professional singer. No, that is your CP/CPK. But how do you know you become a professional singer or not? By looking at your PP and PPK. Whether the crowd is just 10 people listening to you or 1,000 people listening to you or million people listening to you, you will perform diplomatically, right? And that is PP and PPK. All right. So, okay. So what is process capability? But certain slides I will skip because I don't want to touch all these areas like yield and all. I'm not going to touch because you already know it and there is nothing more than that. Output by input and first pass yield, throughput yield, defects per opportunity, defects per million opportunities, defects per 100 units, defects per 1,000 units, defects per 10,000 units, parts per million. These are all quite easier metrics which can be easily understood and calculated. But I'm going to spend a considerable time in process capability indices and the process performance indices. So this and all already you know it. The yield metrics, output by input. The problem with the traditional yield is we don't consider rework, right? Whereas in first pass yield, we even count the reworked unit and subtract it so that we get the first pass yield. And this rolled throughput yield, maybe we can spend a minute here. Rolled throughput yield is applicable to compound processes. You know what is a compound process? A process, two, three process or combinedly gives the result. In such a case, you must prefer to calculate rolled throughput yield. What is rolled throughput yield? The first pass yield of processes at every stage. For example, P1, P2, P3. Look here, P1 is 90, P2 is 80, P3 is 70. Now, which is your bottleneck? P3 is your bottleneck. Now, the overall yield cannot be more than 70%. Once you know the bottleneck, then the overall yield cannot be more than 70% because it is a compound process, means they are linked. The output of one process becomes the input to the next process. So the overall yield if you is found to be 50.4 only. How can you arrive this? You multiply all the three yield. 90% multiplied by 80% multiplied by 70%. So 0.9 multiplied by 0.8 multiplied by zero point 0.7 is 50.4. This is known as rolled throughput yield. Whenever you understand you are responsible for a compound process, you must go for the rolled throughput yield. Don't just settle by looking at the yield at the separate stages. Even if you maintain 90 at every stage, the overall no will be around 70 only. 0.9 multiplied by zero point 0.9 multiplied by zero point 0.9, how much it will be? 72. So you need to understand the rolled throughput yield or the throughput yield should be acceptable, particularly when your process is a compound process, right? So this and all we discussed. I'm not going to recollect it. Defects per million opportunities, the difference between defects and defectives, all the calculations, you know. Okay. Now, we want to design our process. We are responsible for our process performance, right? And now we can design our process in two ways. One is we can design it in a challenging manner. Another one is we can design it in a easily manageable manner. So which is the best one? Easily manageable manner is the best one. So now imagine an elephant taking a bath. An elephant taking a bath. You see the bathtub and see the elephant here. Now you have to tell me whether this process of elephant taking a bath is challenging or easily managed. Right? So let's see what happens. I will play this for you. What do you think? This is easily manageable or it is looking challenging?
Challenge.
Challenging.
Very challenging, very challenging. Simply because what is the reason for the challenge? The
Size of the
size of the elephant and the size of the tub are almost same. Same challenging scenario you will be facing very often if you keep your process size and the tolerance given by the customer almost same. A process is defined by its spread. Yes or no? Any process you are running, it can be defined by the spread of the process. What is the formula to calculate the spread of the process? Any process? Six Sigma. You developed that understanding, yes or no, throughout the course. If I simply calculate standard deviation and then multiply by 6, that will help me to understand the spread of my process. And customer has already given me a tolerance. If the spread of your process and the customer provided tolerance are almost same, like the elephant and the tub, then your process will also be challenging for you. All of you understand? It means, you have selected, no, you have selected a tub, no, similar to the size of the elephant, and that's not going to be a comfortable one. If you want to make the scenario comfortable, what should you do in this particular video? You can't change the elephant, isn't it? But definitely you can change the tub. That is what I'm going to do and see how the situation is changing, right? And now I will play another video and now you understand. Can you see now the process becoming easily manageable? The relative size of the tub and the elephant needs to be understood. And whichever is in your control, make sure the relative size, is not affecting your result. So here we increase the size of the tub, but in a business scenario, what is under your control? Customer tolerance is under your control, or the process spread is under your control? Tell me,
Process
which one
spread.
you can control?
Process spread.
Process spread.
Process spread, it's under your control. Customer's tolerance, you can't control. Customer will tell, this is target, this is upper limit, this is lower limit. You can't change, the customer limits. But you are the process owner. You improve your process. So what will happen? The process spread can be made smaller. If the process spread is made smaller, the scenario will be like, a small elephant taking, tub in a bigger, taking bath in a bigger tub. So you can also make the scenario easily manageable, right? And same logic for this particular example also, size of the car and parking area, which is under your control. Parking area is under your control or the car is under your control. If you are the house owner, both are under your control, right? You can even change the parking area. You can even change the car also. But which is easier? A house we can't keep on modifying. So car has to be purchased properly. When you buy a car, make sure you buy a car which is smaller compared to the parking area available. Similarly, when you develop a process, when you design a process, can you design it in a way the process is smaller compared to the tolerance given by the customer? Yes or no? The spread of the process, if it is smaller compared to the tolerance given by the customer, it will help you to achieve long-term success. All right. So please note here, if this particular first scenario, my car is bigger than the parking area, always the hidden rule is my car must be scratched. Yes or no? Every single shift, if you are rejecting a small percentage of the parts are getting rejected, that means you purchased the wrong car in your factory. Every shift, there will be scratching of the car happening. That is why every shift rejections are happening. How many of you are coming, experiencing these issues? Every shift, there is a rejection. At least 1%, 2%, 3% rejection. That means you are maintaining this situation. Right? You are responsible. Whatever, the way you design and develop your process, and accordingly, the results will happen. But some people, should have carefully designed the process. You see here, the process is so small, or the car is so small compared to the parking area. Now, there are two things that needs to be understood. The car should be smaller in size, and you should have a skilled driver. You should have a very good driver. Yes or no? If you are the driver, you must have a good driving skill, and then you must have a car smaller than the driving area. If the car is smaller than the driving area, tell me, if you are the driver, where will you try to park the car? Would you like to park the car at the center or closer to the walls?
Center.
Or at center.
Center. Because that is the safest point. Even if I make a mistake, still my car cannot touch the wall. That is the idea. Similarly, in any business, the safest area to operate is the customer provided target. The safest, area is customer provided target. Make sure your process is operating in the region of customer provided target. How to know that? Collect data, calculate average out of it, and check whether the average is closer to the target or away from the target. Do you understand? Collect data, collect a sample. Suppose imagine I train all of you to ensure each one of you score 90%. My requirement is clear. Target is 90%. Now, where am I actually operating? Are all of you are traveling with respect to the same goal or not? How do I know? I simply conduct a sample test, calculate the average mark, and I see the average mark, 75. But what is my target? 90. But where is my process currently operating? 75. Because all your marks is directly a representation of the performance, isn't it? So I come to know that my process is shifted leftwards. Somehow I must motivate all of you, encourage all of you to learn, to spend more time in learning, isn't it? And prepare for everything that will happen in the exam. And then slowly what will happen? The average will be pushed upwards. It will move towards the target.
Right.
If the average, class average itself comes to the 90, that is a great scenario I am creating, isn't it? So driving skill means knowing to know where exactly I must drive the car. I must drive the car in the center of the road. If I lag in terms of the driving skill, you know what will happen? My car might tend to touch the walls. Yes or no? If my car is tending to touch the wall, tell me which part of the car will first make contact.
Mirror,
Side
side
mirror.
mirror.
Side
Side
mirror.
mirror.
The side mirrors are nothing but the control limits. The side mirrors are nothing but the control limit. That is why we always ensure our control limit is safe. If the side mirror is safe, the whole car is safe. Yes or no? If you learn to drive a car in a way that no, the side mirror doesn't touch any obstacle, that means you have developed a very good driving skill. So always you just have to make sure your control limits are inside the specification limit. If they are well inside the specification limit, that means you are highly capable. If they are just inside the specification limit, you are just capable. What creates a great scenario? Just capable or highly capable? Highly capable.
Highly capable.
If you design a process in a way that control limits exactly touches the specification limit, the scenario is known as just capable scenario. Something similar to the second picture. You see here. Can you see the car exactly, in the parking area? Even a small mistake, will scratch your side mirror. Yes or no?
Yes.
Even
Yes.
though you are a highly skilled driver, can you handle this kind of scenario every day? Already you are not able to bear the pressure from your boss and pressure from your spouse. So many challenges you have. While managing all of this, will you also manage this kind of scenario? Very difficult, isn't it? So just a capable scenario must be avoided. When you run a process in a just capable scenario, that's the time your CP/CPK will be equal to 1. That's the time your CP/CPK will be equal to 1. That means your control limits are just touching the specification limit. Can you see that, all of you? So CP/CPK equal to 1 means in terms of sigma level, your process is 3 sigma process. Your process is 3
Yes.
sigma process. Pick up the CPK value, multiply by 3. CPK equal to 1. So multiply by 3. Now you are getting your sigma level.
Right.
Sigma level is 3. Sigma level 3 means at least 99.73% of my car is safe. Only a small percentage of the side mirror might scratch. Trust me, this is true only for short term. Till the time your boss is not troubling you much, till the time your spouse is not troubling you much, you will execute your skills properly. Imagine a situation where your spouse is troubling you throughout the day. Now will you drive with the full control now? You will lose your control, isn't it? Now the 99.73 is not applicable. Imagine the rules of normal distribution, cannot be applied now. 99.73 can drop drastically. It can become 95 sometimes. It can become 90 sometimes. Now you understand why your rejections are 5%, 10%. It is 99.73 originally developed, is dropping to 95. So there is a 5% rejection. In certain cases, if the trouble is more, pressure is more, it can drop even up to 90. And so rejection of 10% is also possible. So please note, CP/CPK of 1 or 3 sigma capability, is suitable only for short-term requirement. Just to take care of today's requirement is fine. Parking the car one time is okay. But parking the car multiple times, definitely CP/CPK of 1 is not acceptable. 3 sigma capability is not acceptable. That is why the minimum demand for CP/CPK is 1.33. AIAG has created a guideline. CP/CPK minimum requirement is how much? 1.33. Wherever processes are critical, suppose if your car is a BMW car, it is better to have a bigger parking area, isn't it? And
Yes.
CP/CPK must be 1.67. If your process is less critical, 1.33 required. More critical, 1.67 required. Please note, 1.67 is kind of
Mm.
long-term expectation. Your process will perform in the short term also. Your process will perform in the long term also. Hope all of you understand the scenario here. Am I right? So far, good? All good?
Yes, sir.
Okay. Suppose if my car size is half the size of the parking area and my driving skills are not influenced by spouse or boss or any surrounding, I am able to focus properly. That means the SOPs, whatever recommended, is being practiced in the shop floor. Very rare scenario, isn't it? Whatever SOP is created, people follow exactly the same. And now your car is at the center. Your car is half the size of the parking area. Now you are creating a scenario known as doubly capable. CP/CPK will be equal to 2. Pick up the CPK, multiply by 3. 2 into 3, 6. 6 sigma capability. 6 sigma capability means your success probability is now not 99.73. Now it is much more better than 99.73 and it is 99.999%. And it is 99.999%. And this is true not just for short term, but also for long term. Even if you are, if someone is pressurizing you while parking the car, you will still manage to park the car safely. You are attending a call, right? And there is a pressure scenario getting communicated. But even then, you will be parking the car in a safe manner. So 99.999 is the success rate, long-term success rate from a Six Sigma capable process. Now you are seeing a runway, right? Airplane runway. And imagine you are the pilot and you have to land the aircraft in the runway properly. Now your landing capability, I want to understand. If you are a very good pilot, where will you try to land the aircraft?
The
Middle
center
up.
Preferably at
incline.
the
Middle up.
preferably at the center again. Isn't it? Because center is the safest point. Because air turbulence, there are many uncontrollable factors, you have to go through. So you will try to land the aircraft in the center. Even if things goes wrong, still you will manage to land the aircraft within the runway. Otherwise, it can become a crash landing. Yes or no? All right. So now you see so many landings are happening around the center of the runway. That is clearly communicating the intention of the pilots. That is clearly communicating the skill of the pilot. Yes or no? This particular pilot is a safe to fly pilot. You can believe him and you can comfortably sit with the pilot. He can ensure the safe landing. So now, few more landing points I am capturing. What is your comment about this particular landing? Now, this is little unusual. Can you see that? Little unusual, but still under very much good control. Can you see that? Little unusual, but still the landing is safe. And now this time, around the center only. And again, few more landings. Not bad. Few more landings. After you collect sufficient number of landing points, you are able to realize all the landing points marked in the runway form a bell curve. Yes or no? A peak is happening at the center. Why peak is happening at the center? That is the intention of the pilot. That is how the process is designed. Whatever you designed, that will happen. That is happening, and that is why now the curve is peaking at the center. And in the unusual scenarios, unusual conditions, some of the landing points are moving away from the center line. But even then, they are well within the runway. They are well within the control of the pilot, right? And now this is the target. You can consider this as similar to customer target in any scenario in a business. This is the process average. Can you see the process average and the customer target exactly aligning? This should happen in any process. If this is not happening, please understand you don't know how to target the customer target. Targeting is very, very important, right? Targeting is very, very important. If you don't even know how to target, we can't expect a performance out of it, right? So this process is positioned perfectly on the target. And now this is the maximum extreme I can expect the output of my process to fall within. Nothing but your control limit. If the pilot is making the next landing, definitely it will be within this bell curve only. Yes or no? We have collected sufficient amount of data. And so this is the control limit. The maximum extreme on the right. Similarly, maximum extreme on the left is the lower control limit. The runway ends here. Your customer tolerance ends at a particular point. This is upper spec and this is lower spec. So our target, upper spec, lower spec, upper control limit, lower control limit, process average. You must learn, compare all of this. Any industry, any product, any service, any scenario. What is the customer target? You must know. What is the upper specification limit, lower specification limit? Where is your process operating? The best scenario is process operating around the target. Where are your control limit? The best scenario is control limits always inside the specification limit. The whole game of any business is, gaining the ability to see the control limit always inside the specification limit. No rejections, no frustrations. Clear, all of you? Yes or no?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now, another simple example I am bringing here. So there are certain learnings here. Process average, customer target requirement is both should appear on the same point. And drift, the deviation. If your data are deviating from the target, I mean from the center, that is not good. This is what we call it variation. This is what we call it variation. Every single landing point, if it is moving away from the center, that is what is, indication of a problem. The driver, slowly losing his control. So variation is unpreferred. And then customer tolerance are known as USL. Customer limits are known as USL, LSL. Any output falling outside the USL, LSL are known as, are cases of external failure. Or cases of external failure. If control limits are inside the specification, now you see an observation outside the control limit, it should be recognized as a case of internal failure. I do not know how many of you understand. If control limits are inside the spec, now you see an observation inside the specification, but outside the control limit. How do you want to classify? Do you want to accept it as an usual event? Or do you want to recognize that as an unusual event and take action? You must recognize this as an unusual event. Your car side mirror touching the wall is definitely an unusual event, isn't it? So, any observation falling outside the control limit should be treated as an unusual event or an out of control event, because normally, all the output fall within the control limit only. But suddenly one case outside the control limit, that should be considered an out of control scenario, and action must be initiated immediately. That means an internal failure will be solved internally, will get solved internally. It will never, get passed on to the end user or external customer. Hope all of you understand what I'm speaking. All right. So all of you might also have played this game. Am I right? Shooting the balloons. I give you a big gun with a big barrel, and I will give you 10 bullets. And there is a balloon at the center. What is the color of this balloon? Red color, right? Red color. And now if you hit that red color balloon, I'll pay you 1,000 rupees. But the condition is you must hit all 10 bullets exactly on the red balloon. Then only I will give 10,000, otherwise not. So what is required now? Performance is required and consistent performance is required. Yes or no? All 10 times you have to shoot it. Now, if you have to shoot this and then earn that 10,000 rupees, first thing you should know is you should know how to hold the gun. Yes or no? So, gun with a big barrel. Tell me how, one of you, how to hold the gun. Can I hold the gun pointing the sky like this? Will I be able to shoot it? My target is here. Then what is the point of holding it like this? So this is what I want you to check. Look at your average. If your average is on the target, you are holding the gun perfectly. Only thing you need to do is release the bullet. But if your average is away from the target, you are holding the gun like this. Even if you release the bullet, you know what will happen? You are not going to hit the bullseye. You are going to hit the audience. Yes or no? So you are not a professional shooter. People will easily understand. Whenever average is, moving away from the target, they will understand the unprofessionalism in your job. All right. So statistics helps a lot. And so now, look here. I am holding the gun perfectly like a professional. This is the situation known as average, process average equal to customer target. What is the situation? Process average equal to customer target. Now I release the bullet. First 1,000 rupees. He earned. Again, I release the bullet. Can you see consistency here in the performance? It is not at all deviating. But will you be able to perform the same manner in a workplace? Do you think all your team will cooperate and the supplier will cooperate, vendors will cooperate, machines will cooperate? No. There will be variation. Yes or no? You must measure that variation, control that variation, and if the variations are minimal, somehow you can manage to hit the red balloon repeatedly. But if you are a guy who is poor at controlling the variation, what will happen? You will lose control. And if you lose control, you know what will happen? Instead of hitting the target balloon, which is red, you might hit the first balloons at the first circle. Will you get 1,000 rupees now? According to the rule, you are not going to get any money. Suppose you lose the control further. Now your bullets will start hitting the balloons in the second circle. If you lose further control, then also you don't realize your mistake. You lose further control. Now your your bullets will start hitting the balloons in the third circle. Then also you don't react. You don't take any action. You don't make any correction. You further lose the control. You know what will happen? Now your bullets will start hitting the audience one by one. Is it okay? Do you think your audience will still watch you? Somebody will come and then, ask you to stop. Yes or no? If you demonstrate unprofessionalism, that too in a bigger scale, people will abruptly stop you. Yes or no? They will, in fact, collect back the gun from you. So this is what we call it, See, this is first circle, 1 sigma away from the target. Second circle, 2 sigma away from the target. Third circle, 3 sigma away from the target. If you go beyond 3 sigma, what is that you are shooting? Are you shooting the target or you are shooting the audience? You are an unfit guy to represent, a team in Olympic. Yes or no? So the unprofessionalism is clearly, confirmed. So that is why any observation beyond control limit should be called as an out of control scenario. In control chart, that's what we are doing, isn't it? Every time a point appears outside the control limit, we immediately intervene and then stop the process. So I want all of you to understand that and maintain the same thing in your shop floor also. Now you all will be able to appreciate this equation, mathematical equation, y equal to f of x. Now what is y? The quality of your product with respect to a particular characteristics. That is truly a function of the statistics. What is written here? One is x bar. What is x bar? Process average. Another one is sigma, process variation. If you have good control over the variation, which is sigma, good control over the average, definitely you can produce best in class product. All of you understand the equation here? Quality is a function of x bar and average. Now, what should be the target for your x bar? Your process average must be equal to what? Customer provided target. Very good. Customer provided target. And sigma, when it comes to sigma, the variation should be minimal or you want more variation?
Minimal.
Variation should be minimal.
Should be minimal.
If your sigma value standard deviations are very, very low, that confirms you have a greater level of control over your process. which is always good, isn't it? Now, right after the lunch, we are discussing. All of you are able to pay full attention?
Yes.
Or somebody
Yes, sir.
sleeping here? No, all are
Yes.
paying. That means, that means we have good control over our whole process.
Excuse me,
We
sir.
have good. Yes.
Sir, I have a question for a graphical representation of a normal curve. If we have a
Okay.
Cp equal to 2 and Cpk equal to 0.75 or somewhere 0.6,
No, that is
so
not
how
possible.
to interpret this?
No, that is not possible. You will come to know that. I'll show you that, right? Always your
Okay.
CPK will be lesser than CP, right? If you see, if you are not what to say, if you are not able to sing properly in the bathroom itself, you cannot sing on the stage, isn't it?
Yes.
So CP and CPK, there are two things, and your CPK cannot be more than CP, right?
No, no,
And you
sir.
will
I
understand
am I am I am saying that Cp equal to 2 and Cpk is 0.75.
that. Okay. Oh, that's possible. That's possible. CPK is 2 and sorry, CP is 2 and CPK is 0.7, isn't it?
Yes, yes. So how
That
to
means,
interpret
no,
this?
sir, now I understood his question. CP equal to 2 and CPK is 0.7 means your process is shifted.
Yeah, it is shifted, but it is left shifted or right shifted.
Yeah, that you need to look at your data and then look at your
Okay.
average and understand. If
Sir,
your
can I
average
come,
is
sir?
below the target, process is shifted left. If your average is above the target, process is shifted right.
Okay.
Clear?
Okay.
But that means you are making a mistake.
In detail. Okay, so let me continue with the same thing. All right. So now this is the normal distribution. Now you all know everything about normal distribution. Yes or no? You see the curve is symmetrical at the center. Your curve is symmetrical at the center. That means 50% on the right, 50% on the left. And what is there at the center? Process average. Look at the control limit, 3 standard deviation away from the center, control limit. Then this point is known as warning limit. This point is known as 1 sigma limit. If you consider 1 sigma limit, what percentage of the curve will be covered? 68.27. If you consider warning limit, what will be the percentage of the area of the curve covered? 95.45. If you can go up to control limit, 99.73% of the points or 99.73% of the area under the curve will be covered if you go up to control limits. Always the total area under the curve is 100%. Right? The total area under the sun. How much area we have under the sun? 100%. Isn't it? So something similar to that. Total area under the curve is 100. Okay. So, and now look at the scenario and tell me whether this process is capable or not. Customer has given you this much tolerance and your whole process, always to represent a whole process, you indicate up to 3 sigma limit. That is enough. This is a normal practice, right? So the whole process you are able to see well inside the spec. Is this process capable?
Yes.
Definitely
Yes.
capable. Definitely capable.
Yes.
And now what happened? The process has got shifted. Can you see that? Your
Yes.
process has got shifted. Maybe for some reason you need to find out. But still, the problem is not, getting elevated up to the, end user. Can you see that? Even though the
Yes, sir.
process is shifted, still everything is well inside the specification. But however, you don't have to wait, till your process and the products, go beyond the spec. The moment you understand there is a shift happen, can't you pull back the process? If you pull back, what is the advantage? Again, if it shift, the problem, cannot get elevated. That is the idea. So at right time, you must take the action. Now what happened? The process is shifted
Left.
towards leftwards. Now what should we do? We should pull back the whole process. Pull back the whole process. This is called shifting the process. If I don't pull back, what will happen? Again, within some other time, all the process, will be, or majority of the process will be operating outside the spec. Certain percentage of your products will get rejected even by the customer. So this is the, look at the scenario now.
Not capable.
What is the problem here? Your
Not
process
capable.
spread is too high. You need to know what percentage of the curve is appearing inside the spec. Now tell me what percentage of the curve is appearing inside the spec.
95.
95.
So if you produce 1,000 parts, 950 parts will be safe, but 50 parts will be rejected. Your rejection rate is 5%. You don't have to produce 1,000 parts, or you don't have to produce 10,000 parts, or you don't have to produce 1 million parts. It is an estimation, please note. If you have quality samples with sufficient numbers, you can judge all of these things percentage, even before completing the full production. Cp, Cpk are estimated values. Very good. And now in this case, your Cp, Cpk will be less than 1 or more than 1?
Less than 1.
Less
Less
than
than
1.
Less than 1. Very good. And so this is the formula for your Cp, Cpk. USL minus LSL, customer provided tolerance. The spread of the customer tolerance is collected. We are dividing it by the spread of the process. Spread of this process is the vehicle. Customer provided tolerance is the road. Vehicle should be smaller than the road, yes or no? If vehicle
Yes,
is
sir.
smaller than the road, your Cp value will be more than 1. If vehicle is bigger than the road, your Cp value is smaller. So Cp smaller indicates, a trouble. So that's why, our Cp should be always more than 1. But please note, having a smaller car doesn't completely guarantee that, you will reach the destination. The driver sitting inside the car should also be smarter, yes or no? Car is smaller than the road, and the driver sitting in the car should also be a skilled driver. So, if you check the driver also, I mean the skill of the driver also, in addition to the size of the car, that means you are believing in CPK. Because for calculating CPK, you see, process average is also considered. Here, there is no average considered. We are not at all worried where the driver is actually driving, whether he is driving on the right side or left side or properly at the center, that we are not checking. Whereas here, we are checking the position of the process. So that is why CPK is a better metric compared to CP. CP is known as potential ratio, potential process capability ratio. CPK is known as process capability index, which gives the realistic measure of capability, CPK. Why? It not just compares the size of the car, also checks the driver's skill. Size of the car is 6 sigma, driver's skill is process average. Clear?
Yes.
Now look at this condition. In this condition, is your process operating at the center properly?
Yes.
If there is no shifting, from the shifting of the process center, CPK will be same. You just calculate any one. You don't have to calculate both. Only if the shifting happens, you must calculate CPK. Otherwise, CP will be equal to CPK. So in this scenario, I calculate CP 1.67. So what will be the value of CPK also?
1.6.
Same 1.67. Now the process is capable. The process is definitely capable, no rejections. Now this scenario, what happened to your process now? What happened to your process?
Shifted right.
Shifted right side. The same process, just last week, it was performing well. Same machine, same operator, everything is same. But now this week, I see, every day in the week, there is a rejection now. This is because my process is shifted. Now, what could have been the reason? Somebody should have changed the setting. Yes or no? Or the raw material quality suddenly got changed. Last week, everything was fine, but this week there is a problem. This is how, process shifting can happen. So now now your CP remains same. Your CP remains same, but CPK has now fallen below 1. Can you see that, all of you? Right? And that's why, the formula for CPK is developed by utilizing X bar in addition to sigma. So we'll see those formulas also, don't worry. You see here, this is the best slide to understand the formula of CPK. And see this distance, the total distance is the tolerance given by the customer. So no, you divide the tolerance given by the customer into two equal parts. The right side is blue part, the left side is green part. Since I divided equally, the blue part and green part will be equal. Yes or no? The blue part and green part will be equal in size. Similarly, the spread of the process is 6 sigma. I divide that into two parts. So 3 sigma on the right, 3 sigma on the left. Now what you need to do is take the right half of the tolerance divided by right half of the process. Do you understand? Right half of the tolerance divided by right half of the process spread. You do it both sides. If the process is not at all shifted, the right side ratio will be equal to left side ratio. Am I right? All of you are able to follow me? The process center is here. If the process, as long as is centered here, the right side ratio will be equal to left side ratio. The right side ratio is known as Cp upper. The left side ratio is known as Cp lower. Am I right? So in this condition, if you calculate Cp upper, 1.66, Cp lower, that is also 1.66. If both are same, you pick up any one. That will be the value of Cpk. Hope it is clear to all of you. The formula for Cpk is now understood. USL minus X bar by 3 sigma. Another thing
Yes, sir.
is X bar minus LSL by 3 sigma.
3 sigma.
Out, if both are same, no confusion. If both are different, you must pick up the minimum. If Cp upper goes down, that means process is shifted to the right side. If Cp lower goes down, process is shifted to the left side. And now look at the condition now. Your process is shifted to the right side. Am I right? Can you see from the slide? Your process is shifted to the right side. Now what happened to the numerator? The blue bar has reduced in size. Can you see that? The blue bar reduced in size. And now you find out this ratio as well as this ratio. Now Cp upper, right side ratio is Cp upper and this is Cp lower. Now you can understand Cp upper has reduced. Can you see here? 0.833. Cp lower is 2.5. Out of the two, you should pick up the minimum one. And that is assigned to the CPK value. So if the process average is shifting from the target, definitely no, your CPK will be different. And see what is required to say that a process is capable. CPK must be more than 1.67. Whenever you see CPK more than 1.67, you can simply declare your process is capable. That means your outputs are consistently good. Your outputs are consistently good. No rejections. Rejections are not possible. But if CP is more than 1.67, if you don't know anything about CPK, you only know CP is more than 1.67, then you must conclude that your outputs are consistent. You should not say consistently good. Please note, there is a difference in saying your outputs are consistent means no, you are getting the same results, similar results. So CP can only help you to understand the consistency in the result, not the capability, right? And then in an ideal scenario, CP must be equal to CPK. If CP equal to CPK, your process has not shifted. If CP and CPK are different, it is an evidence that your process got shifted. You have to check whether it shifted on the right side or shifted on the left side and accordingly take action. Right? I think somebody wanted to ask a question at this stage. Shankar, you want to ask something? Some question here? Somebody raised a hand, I've seen.
Sir, when we know the process is shifted during the CP-CPK value, how much is the difference?
Okay. See, if you want to know whether your process is shifted or not, you just have to look at your process average. You have to look at your process average. Now, in this condition, what is the process average? You see here, X bar is not 40. That means let us say 42 or 43. But what is the target? 40. Since target is 40, but my process average is 43, I now conclude my process is shifted. That too to the right side because 43 is above 40. Hope I have answered your question.
Okay, when we give the average, when we don't have the average, only CP/CPK value is there. How can we is able to identify processes shift or not?
No. See, that means you are using the tools in an inappropriate manner. Because CP/CPK value cannot be calculated without the process average and process standard deviation, right? So you must know it. CP/CPK, if you cannot calculate CP/CPK without data. Agree, all of you? You cannot calculate CP/CPK without data. If you have a data, what is the problem in calculating the average? You calculate. All right, do you understand? If you have data, please calculate average. And why do you want to avoid referring to the data and then put yourself unnecessarily in a challenging situation? Better you please calculate the average and then decide. Okay, RK sir, you want to add something here?
Yeah.
So we'll just quickly. Yeah, yes, sir. Please.
Can we just go back to the same slide where you explained about CP/CPK? The bell
Yeah,
curve?
sure. So you want to see this curve, right?
No, sir. The curve. Yeah.
Yes, sir. This one?
Yeah. So
Your process is shifted in the shifted condition.
and a slide before, sir.
Oh, sure.
And everything was centered actually.
Yeah, everything is properly centered. Variations are also variation wise also okay. Location wise also okay. Great scenario. Your CP and CPK are same in this situation. This is what is required. Good to go?
Yes, sir.
Okay, now let's take one simple example, right? And see here an electronic manufacturing process. The specification for the current flow is 100 plus or minus 10 milliampere. Target is clear. Upper spec is clear. Lower spec is clear. The process mean and process standard deviation are 107 and 1.5. Now calculate the CP/CPK. Now same formulas. Don't worry, you can feed all this information in Minitab and generate the report. But for knowledge gaining, I am showing here. Everything is declared. CP is written. CP equal to 2.22. Now what is your conclusion looking at CP equal to 2.22? If I ask you to conclude, what will be your conclusion? I am only showing you CP. Now what will be deciding now? Process
Highly
is
capable.
The process is capable.
No. Don't use the word capability. I told you. I am showing you only CP. You can use the word consistency.
Consistent.
Consistency.
The process is performing consistently. That means variations are less. It doesn't mean that you are producing good product. You are consistently scoring marks, but whether you are consistently passing the exam or consistently failing the exam, that is still not guaranteed, right? You have to know. So now CPK we are calculating. When I calculate CPK, CP upper and CP lower, I am going formula wise. My CP upper is 0.66, but CP lower is 3.77. That means I now you easily understand my process is shifted to the right side because CP upper has gone down. Now, what is my conclusion? CPK equal to 0.66. My process is not capable. So that's why I told you if you want to conclude looking at the CP, use only the word consistency. But if you look at CPK, use the word capable. Capable means everything is inside the spec. Very good. So in this situation, CP and CPK are different. So the inference is process is shifted. That too towards yourself. What is the action to be taken? Your process must be pulled leftwards. Yes or no? I mean your process should center move the process center towards customer target. I mean, leftwards you have to move. And CP equal to 2.22. Process is under statistical control. Control wise is fine, right? No action required. You don't have to worry about variation. But CPK equal to 0.66, process not capable. So now you have to do both. That means you have to moving the mean is the solution. Moving the mean is the statistical solution. But how can you move the mean in real time? You have to, apply your, what to say, all the process knowledge and, understand the current condition. Like I want to shift all your, average mark from 75 to 95. What should I do? If all of you have to, help me to improve the class average from 75 to 95, what should I do? I may conduct some extra classes. I may give more orientation towards the exam. These are the real-time actions. Similarly, what works best in your process, you must understand. Now, another scenario, an extrusion die, aluminum rod, the diameter of the rod is CPQ. Specifications are 0.5035 plus or minus. So target is clear, upper spec, lower spec is clear. The process average and standard deviation are directly given to you. You don't have to, worry about calculating this. It's given. Now calculate Cp, Cpk. Now my Cp equal to 1.11. What do you understand now? Your process variations are high or low?
The process
According to the
variation
guideline,
is high.
according to the guideline, variations are high. 1.67 is, what is our guideline? So variations are high. So take steps to reduce the variation. Another thing, CPK is 0.66. So that means your process is shifted. In addition to higher variation, shifting is also happening. And which side? You will look at the upper or lower. Now this time lower is 0.66. So process is shifted leftwards.
Left.
This is how you must understand. And always people think that CP/CPK can only be used in manufacturing industry. Even right now, all my examples are from the manufacturing industry, isn't it? It doesn't mean that CP/CPK can only be used in manufacturing industry. It can be used in all scenarios where data type is continuous. And this case study simply confirms that CP/CPK can be used, in all your industry. A 5-star restaurant manager, he want to, ensure all the customers, all the people who are come for, dining with the hotel, they are always satisfied. So he understood customers prefer the food to be maintained at a temperature between 39 and 49 degrees Celsius. Now, what is the upper spec?
49 degrees.
49. Lower spec is 39.
39.
Always the center is the target, right? When you have an upper spec and lower spec, center is the target. Target is clear, upper spec is clear, lower spec is clear. And now he often collects the food temperature during the lunch time, and he found that on an average the food temperature is 40 degrees Celsius. And the standard deviation of his readings are 2 degrees Celsius. Now, if this is the case, what is the current CPK? Look here, current CPK for his case is, there are two values coming, 1.5 and the other one is 0.166. Now, what does he understand? CPK is 0.166. That means his process is
Left side shifted.
not capable. You can see the average, having the tendency of moving leftwards. Can you see that? What is the current average now? 40. But we want the food to be, somewhere at the center, food temperature to be. So this restaurant manager, he could assess his own capability of maintaining the food at the appropriate temperature to his customer with the help of CPK. Do you understand? So, what is the requirement to use CP/CPK? Your data type must be continuous data.
Continuous.
Please ask yourself, are you dealing with the continuous data in your profession? Turnaround time is a continuous data. Yes or no? Your sales, everyday sales is a continuous data. Yes or no? If you are a digital marketer, the conversion rate, and then the number of impressions. So these are all, continuous data. Yes, Daljit Singh sir, you can go ahead with your question. Yes, sir.
Sir, when we are reading the solution, it says upper specific limit 49 degrees Celsius and lower is 39, and standard deviation 2 and mean is 40. The solution itself indicating that there is a shift toward the lower specification, whereas the mean is 40.
Yeah, correct. In the current condition, your mean is shifted left to, downwards.
Yes, yes.
And so most of the time you will be serving cold, food in what to say, with food to your customers with an inappropriate temperature. Because customer has clearly communicated the food must be between 39 to 49. Specifications are available, but you are not able to maintain your food in that temperature. Correct? That means process requires some improvement. You do something to ensure, the food is available always within the required temperature range, and the range is 39 to 49. If you wanted to make sure the food is always within this range, then process average must be pushed a little upward. If you push too much upward, then this is too hot. If you push downward, then it is too cold. Customer prefers between 39 to 49. So this example I brought here only to let you understand CP, CPK can be used in all industries.
Sir,
Now tell me CP. Yes, sir.
Sorry, I have one clarification here, because here this higher the temperature is better. So
No, it's not like if customer says I want 39 to 49, then that means lower limit is also there, upper limit is also there. If you want to say higher the better, then you have to say minimum 39 or minimum 40. If customer says minimum 40, then in that case, no, you only have lower spec. Below 40 is the problem. So whenever the situation becomes one-sided tolerance, you just look at CPK. You don't have to look at CP.
So maybe my control can be something like 44 to 48, something like that. I can do the customer tolerance. I can put internal limit.
Possible.
Yeah.
All right, now answer this question. CP equal to 0.94, CPK equal to 0.33. Process is not capable. What action is required now?
Sir, is it audible? Sir,
Yes, Balaji, audible.
Yes, sir. One side unilateral tolerance, no, sir. One side tolerance.
Yes.
That you me that glimpse, sir. Actually, both the side specification is fine now. It's clearly understood. One side.
Yeah, if one-sided tolerance, if you are working with one-sided tolerance, that is what I told you. For in your case, you don't have to look at CP. Since the process, is the tolerance is unilateral, you must always base your decisions with the help of CPK only, not CP, because the chance of making misleading and wrong decisions will be higher if you tend to look at CP, because the process is one-sided, isn't it? So you don't have to look at CP at all. CP is not required for unilateral tolerances. Only CPK is required.
Okay, sir. Okay.
Clear?
Sir,
So
in addition to this question,
lower is
Yes.
Sir, in addition to when I say one-sided tolerance, it means no negative tolerance allowed, only positive is allowed.
No, it can be either way. Can be either way.
What does it mean by one-sided tolerance?
No, sometimes, the weight of a particular product should be minimum, 10 grams. If you give more weight, customer not bothered. But anything less than 10, he is not able to accept. He is not willing to accept. Now, this is a unilateral tolerance, right? Weight should be minimum 10 grams. Now, only lower spec exists. Upper spec, there is no upper spec. In certain cases, let's say, the weight should be lesser than, let's say, it should be lesser than 8 grams. A particular ingredient, should be, fat content should be less than 15%. Now, upper spec only exists. Can you see that anything below 15 is okay, but nothing above 15 is unacceptable? Right? Above 15 is unacceptable. Yes.
Sir, if above 15 is not acceptable and below 15 is acceptable, then the CPK in the lower side will be recommended?
No. See, above 15, see, in any case, CPK should be more than 1.67. Whether it is unilateral or bilateral, whether the limit is above 15 or below 15, whatever it is, that is a customer requirement. Based on that only, the formula for CPK is designed. Yes or no? We just now have seen everything. All that you need to do is to go through the steps, calculate the CPK. And if CPK is more than 1.67, all good. Otherwise, unacceptable. Okay, coming here. Look at CP-CPK, 0.94, 0.33. Both are under trouble. Can you see that? CP also under trouble, CPK also under trouble. Now, what are the actions you need to do? Two actions. One is correct the average. Correct the average means move it towards the target. Another thing is reduce the variation. So both you need to do. So these are the things I want you to have a proper understanding about CP and CPK. And tomorrow morning, I would like to speak to you about PP and PPK. Before I conclude, please tell me, if you have to choose one player out of the two here to represent Indian team in the next T20 series, which India will be playing, I think it is starting today, right, against Sri Lanka. If you are in the selection committee, whom you will choose? You will prefer Virendra Sehwag to participate in our Indian team or Surya Kumar Yadav?
Surya Kumar Yadav.
Surya Kumar performance.
But we very well know Sehwag was also a good player, isn't it?
For 2020, Sehwag was good.
But no, but considering the today's condition, he cannot perform. Both of them proved to be capable batsmen. But who is a performing batsman right now?
Surya Kumar Yadav.
So we all need Surya Kumar right now. Same is the logic. We need a healthier PP-PPK and not just CP-CPK. Clear? Similarly, the choice between Kapil Dev and Bumrah. Whom do you want to play for India? Bumrah. That means you always tend to choose the performer, not just the capable one. Yes or no? So process performance indices or need to be maintained at a healthier level for your long-term success. If you really wanted to win matches, then you must have a healthier PP-PPK. If the whole game is just for 5 minutes, just one over, you want the batsman to play, then probably you can try with the Sehwag. He may play for 5 or 6 ball, but a complete match only Surya Kumar only can play. Yes or no? Same is the logic. If you are looking at the short-term requirement, then CP-CPK can fulfill. But if you are looking at the long-term requirement, definitely PP-PPK have to be strengthened. Tomorrow, fresh morning, we'll be talking about the formulas also. All right. So this completes my session on CP-CPK and CP-CPK. The PP-PPK will be discussed tomorrow morning.